Millions of American kitchens in the 1940s had a refrigerator with no compressor, a flame-heated ammonia and water. The ammonia evaporated and pulled heat from the air. That cycle was patented in 1859. It cooled homes for decades. Then it vanished from every building code in America. By the end of this video, you will discover how a $45 ammonia loop buried in your yard becomes a geothermal freezer. The system works like this. Ammonia dissolves in water the way sugar dissolves in tea. Apply heat to that solution and the ammonia separates as vapor. It rises into a condenser where it releases that heat to the surrounding environment and returns to liquid. The liquid ammonia passes through a narrow restriction and drops in pressure. When pressure drops, the ammonia evaporates. And when ammonia evaporates, it absorbs heat from everything around it. That evaporation is the cooling. The cooled ammonia vapor flows back into the water, dissolves again, and the loop restarts. No piston, no compressor motor, no spinning fan blade. The only thing moving is the fluid itself. The entire cycle runs on a heat. Here is what the materials actually cost. Copper or steel pipe for the heat exchangers runs $15 to $20 at any hardware store. Fittings, valves, and connectors add $10 to $15. Ammonia solution costs roughly $3 to $5 per kilogram from any agricultural supply dealer. A small 12-volt direct current circulation pump runs about $10. Total cost for the core absorption loop sits between $35 and $50. That is less than 1 month of air conditioning in most of the country. This is the thermodynamic circuit, not a turnkey installed system. That distinction matters, and this video will be honest about it. Now here is where the loop becomes a geothermal freezer. Take the condenser coil and bury it 2 meters below grade. Pack it in compacted sand for maximum thermal contact. At that depth, the Earth holds steady between 12 and 15 degrees Celsius year-round. Summer heat waves and winter polar vortexes never reach down that far. That constant underground coolness becomes your heat sink. The ammonia condenses underground, pushes its heat into soil that simply absorbs it, and dissipates it into the broader Earth mass. No outdoor fan unit blowing hot air across your yard. No noise, no vibration. The ground is the condenser. The earth beneath your lawn is your cooling infrastructure. Engineers measure cooling efficiency using something called coefficient of performance. Your backyard air conditioning unit achieves a COP between 2.5 and 3.5. A basic single-effect ammonia absorption system achieves a thermodynamic COP around 0.5 to 0.7. That looks worse on paper. But COP measures cooling output per unit of energy input. When the heat driving the cycle is free from a rooftop solar thermal collector or waste heat from a wood stove flue, the only electricity consumed is a small pump drawing 15 to 40 watts. When calculating the efficiency based only on the electrical power needed to run the small circulation pump, the effective COP can reach 12 to 18. This highlights the massive potential to save electricity by utilizing free heat sources like solar thermal collectors. While a traditional air conditioner requires 3,000 watts of electricity to cool a space, this system achieves a cooling effect while only drawing 40 watts of electricity to move the fluid. This change in energy usage represents a major shift in how we power our homes. The refrigerant itself is classified as R717, zero ozone depletion potential, zero global warming potential. It exists naturally in soil, water, and atmosphere. The International Institute of Refrigeration in Paris confirms ammonia is the most thermodynamically efficient natural refrigerant known. It costs $3 a kilogram. Nobody holds a patent on it. Nobody can. Zero ozone damage, zero warming. No patent holder, no licensing fee, no moving parts, and your grandmother had one in her kitchen. This is not new science. This is technology you were made to forget. Between 1926 and 1957, the Servel Corporation operated a factory in Evansville, Indiana, producing millions of gas absorption refrigerators. These machines sat in American kitchens from coast to coast. They ran on natural gas or kerosene, no compressor, no electric motor, nearly silent, projected lifespan exceeding 40 years. Documented Servel units from the 1930s are still running in rural American homes today. Families stacking food into the same refrigerator their grandparents bought. 90 years without a single compressor replacement because there was no compressor to replace. Before the Servel came the Crossley Icy Ball. Introduced in 1928, it was a portable ammonia absorption device roughly the size of a bowling ball. You heated one end over a campfire for 90 minutes. It made ice for 24 hours. The Sears Roebuck catalog sold it for $18 delivered to your door. Farmers in Kentucky and ranchers in Montana had refrigeration before they had electricity. The ammonia loop did not need the power grid. It predated it. The physics traces back even further. In 1859, a French engineer named Ferdinand Carré filed a patent in Paris for the first ammonia absorption refrigeration machine. No residential electricity existed anywhere on Earth. No mechanical compressor had been invented yet. Carré heated ammonia and water with a flame and produced ice from thin air. 3 years later, during the American Civil War, Confederate military hospitals in the Gulf South needed ice desperately. They imported Carré machines to New Orleans. Records show those machines producing 3,000 pounds of ice per day. Cooling, powered by fire in the Louisiana summer heat. In 1922, two Swedish engineering students at the Royal Institute of Technology in Stockholm created something remarkable. Baltzar von Platen and Carl Munters designed a three-fluid absorption system using ammonia, water, and hydrogen gas. No pump, no moving parts of any kind. A completely sealed loop driven by nothing more than a small flame. The Electrolux company licensed the patent immediately. That invention became the foundation for the Servel refrigerator that later cooled 30 million American kitchens. 8 years later in Berlin, Albert Einstein and Leo Szilard filed United States patent number 1,781,541. It described an improved absorption refrigerator with zero mechanical components. Einstein stated his motivation came from reading a newspaper account of a Berlin family killed by toxic fumes leaking through a failed compressor seal. He wanted to design a refrigerator that could not mechanically fail. He succeeded. A Nobel laureate built a better cooling system with no moving parts. The industry had other plans for it. 165 years of continuous engineering. Carré, Platen, Munters, Einstein, Szilard, Servel, millions of proven installations. The technology was not primitive, it was the standard. Then in 17 years, it went from 30% of the American refrigerator market to 4%. Not because it broke, not because something better replaced it, because someone figured out how to make you pay every month for something that used to cost nothing. In 1930, a chemist named Thomas Midgley Jr. stood before the American Chemical Society and performed a demonstration that changed the cooling industry forever. He inhaled a lungful of dichlorodifluoromethane and blew out a candle. The room applauded. The compound was trademarked Freon 12. DuPont held the patent. From that moment forward, the refrigerant inside your cooling system belonged to a corporation. Ammonia belongs to no one. It falls from the sky when it rains. You cannot patent rain. And that was the problem. Consider the two business models side by side. A sealed Servel absorption unit lasted 40 years. No refrigerant recharge, no compressor burnout, no service calls. A vapor compression unit running on proprietary freons lasted 12 to 15 years. It needed periodic recharging with patented refrigerant costing $75 to $150 per visit. The replacement cycle ran $2,000 to $5,000. Executives in corporate boardrooms looked at those numbers and made a decision. Absorption cooling was not a worse product. It was a worse revenue stream for the companies selling the hardware. Through the 1940s and 50s, General Electric and Westinghouse ran national advertising campaigns positioning compressor refrigerators as modern, electric, and progressive. Trade publications ran full-page advertorials framing gas absorption as outdated, rural, and old-fashioned. A 1930 Carrier Corporation engineering manual dismissed ammonia cooling as suitable only for cellars and food storage. Contractors reading those trade magazines absorbed the message. Homebuyers flipping through Life and the Saturday Evening Post absorbed it too. Servel's market share collapsed from over 30% in 1940 to under 4% by 1957. 17 years of marketing erased 40 years of engineering. Then came the codes. ASHRAE, Standard 15, first published in 1919, was revised through the 50s and 60s to progressively restrict ammonia in occupied spaces. The Uniform Mechanical Code, Section 1101, confined ammonia systems to dedicated machinery rooms. The International Mechanical Code layered on requirements for dedicated ventilation, continuous leak detection, and emergency shutoff. Inspectors shaking their heads at permit applications. Contractors told not to bother filing. Each revision made residential absorption cooling harder to install legally, not banned outright, just made nearly impossible to build. Ammonia is toxic at high concentrations. That is true. Natural gas is toxic too. So is carbon monoxide from every combustion appliance already inside American homes. The ammonia charge in a residential absorption loop is a fraction of the concentration that triggers the safety thresholds these codes were written around. The risk is real. The regulatory response is disproportionate, and the disproportionality is very profitable for every company that sells you a compressor. The codes are written against you. The committees that draft them are staffed by the companies selling the alternative. But physics does not read building codes, and in the rest of the world they never stopped using these systems. In Germany, residential ammonia absorption heat pumps are legal and certified under DIN EN 378. The Rober Corporation manufactures a gas-fired ammonia absorption heat pump called the GAHP series that delivers both heating and cooling for single-family homes. It carries Eurovent certification, over 20,000 documented installations across Europe, families in Munich and Hamburg, cooling their homes with the same ammonia cycle your grandmother used in Evansville. You can buy one in Berlin. You cannot install one in Baltimore. In Japan, absorption chillers cool an estimated 60% of all commercial buildings. Manufacturers Yazaki and Kawasaki produce units ranging from residential 10-kilowatt systems to industrial megawatt installations. Office workers in Tokyo sitting in buildings cooled by ammonia. Japan never legislated the technology out of occupied spaces the way America did. At the Indian Institutes of Technology in Madras and Jodhpur, researchers have documented solar thermal ammonia absorption chiller installations across Rajasthan. 5 to 10 kilowatts of cooling generated entirely from rooftop solar collectors. Peer-reviewed performance data published in Energy and Buildings confirms near-zero operating costs after installation. Villages in the desert cooling their homes with sunlight, ammonia, and buried pipe. Here is the number that should make you angry. Approximately 90% of large-scale cold storage and food processing facilities worldwide run on ammonia refrigeration. Every frozen food warehouse, every meat packing plant, every ice cream factory. The industrial world chose ammonia because it is the most efficient refrigerant that exists. The restriction applies only to the one building where you could use it to eliminate a monthly electric bill. Your house. The Air Conditioning, Heating, and Refrigeration Institute spends significant resources every year on lobbying and political activities to influence the standards and policies that shape the cooling industry. Lobbyists walking the hallways of state capitals and federal agencies. In 2019, ASHRAE Technical Committee 6.8 rejected a proposal to create a residential performance pathway for ammonia absorption systems. The committee cited insufficient domestic performance data while ignoring 30 years of European documentation. Analysis of committee membership revealed 60 to 70% representation from compressor and synthetic refrigerant manufacturers. The people writing the restrictions are the people selling you the compressor. That is why ammonia absorption is restricted. Follow the money and the answer is never complicated. But the physics works regardless of what any inspector or code official says. The system has 4 components: a generator vessel, where ammonia and water solution is heated and ammonia separates as vapor, a condenser where that vapor releases heat and returns to liquid, an evaporator where liquid ammonia absorbs heat from surrounding air, producing the cooling, an absorber where ammonia recombines with water and the cycle starts over, connecting pipe, a small pump, or a passive thermosiphon arrangement that uses the heat itself to drive the flow. That is the entire machine. Bury the condenser coil 2 meters below grade in compacted sand bedding for intimate thermal contact with the surrounding soil. The earth at that depth holds 12 to 15 degrees Celsius regardless of what the surface thermometer reads. The ammonia condenses underground, rejects its heat into a thermal mass that has not fluctuated in thousands of years. No outdoor condenser fan, no hot exhaust, just pipe, sand, soil, and physics. The ground beneath your yard does what it has always done. It holds steady while everything above it changes. The heat source can be a flat plate solar thermal collector generating 80 to 100 degrees Celsius on your roof. It can be waste heat piped from a wood stove flue. It can be a small propane burner at minimal consumption. The absorption cycle needs heat, not electricity. Whatever heat source you already own becomes the engine. Be honest about what this requires. Ammonia is toxic at concentration. A leak in an enclosed space is dangerous. Proper ventilation is not optional. This system belongs outdoors or in a dedicated utility space with an ammonia leak detector and mechanical exhaust. The $45 figure covers the core absorption loop materials, a complete ground-coupled installation with trenching, a solar collector, piping, and safety equipment costs considerably more. Respect that distinction. Anyone who tells you otherwise is selling something. The COP of a single-effect absorption system on a strict thermodynamic basis is 0.5 to 0.7, lower than a compressor, but when the heat input is sunlight striking your roof or waste heat leaving your chimney, the electricity consumed is 15 to 40 watts. Your conventional air conditioner pulls 3,000 watts to deliver a COP of 3. This loop pulls 40 watts to deliver cooling all summer. The economics do not just compete, they invert. Small charge ammonia systems below EPA-SNAP program thresholds often fall outside the strictest code provisions. Agricultural buildings and detached workshops draw less regulatory scrutiny than primary residences. The language you choose on a permit application shapes how it gets received. That is not legal advice. It is an observation about how words shape what regulators see. The physics has not changed since 1859. Ammonia still dissolves in water. Heat still drives it out. Evaporation still pulls heat from the air. $45 in pipe, fittings, and ammonia solution. No compressor, no moving parts, no patent. 2 meters below your yard, the Earth holds steady at 12 degrees. It held that temperature when Carré filed his patent in Paris. It held it when Einstein filed his in Berlin. It holds it right now beneath your lawn. Bury the condenser. Let the ground do what it has done since before anyone was measuring. It works for Yazaki in Tokyo. It works for Rober in Milan. It works in 20,000 European homes and 90% of every cold storage warehouse on the planet. The only place it does not work is inside the code book written by the people who sell you the compressor. That is why it is restricted. That has always been why.